I'm going to give a brief overview of graphing angles in standard position, and afterwards I'm going to talk a little bit about converting between degrees and radians. In general, if you graph an angle in standard position, the idea is you're superimposing that angle onto a coordinate plane, and it gives us some insight a little bit different than what you might see if you don't graph on a coordinate plane. For example, if I wanted to graph a 120-degree angle, you start out with one side along the x-axis, vertex at the origin. This is referred to as the beginning side of the angle. And interestingly, an angle opens in a positive direction counterclockwise. It actually moves through the first quadrant. So in this case, a 120-degree angle would go up to 90. It would go past that, looking something kind of like this. And we can say that's a 120-degree angle. This is referred to as the terminal, the ending side of the angle. If I have an angle that is graphed along either the x or the y-axis, for example, a 90-degree angle, that angle is referred to as a quadrantal angle. So I'm not going to show that on this graph here, but that's another term you're going to hear from time to time. So that's the basic idea of graphing in standard position. Now the follow-up to that, the idea of converting between degrees and radians. The central idea behind graphing in radians, and there are different ways to show this, but the central idea goes back to an idea known as the unit circle. And the concept of the unit circle is very simple. A unit circle is a circle that has a radius of 1. And the idea is an angle is always infinitely extendable. So you can always plot an angle in a way so it crosses over, so it overlaps a unit circle. And the idea is that if a unit circle has a radius of 1, the circumference is 2 pi r, which is going to be 2 pi. And so a complete circle is considered to be 2 pi radians, is the degree measure that, or is basically what's used instead of degrees. So an angle that is a complete circle would be an angle with a measure of 2 pi radians. In other words, it goes around a complete unit circle. If it goes around a half unit circle, it would go around the half circle basically would be pi radians instead. That's the equivalent of 180 degrees. So basically the key facts that you want to know here, we know that 2 pi radians would be equal to 360 degrees. If you take half of that, pi radians then as a result would be equal to 180 degrees. And most of the time, that's the fact that most people use to make their conversion. You can make your conversions using proportions. I'll show you how to do that in a minute. But really it's a lot simpler than that, because if you think about it, any pi radian measure is the equivalent of 180 degrees. So you can really remove the pi and replace it with 180 degrees, and you can get your calculation real easily. So for example, 2 times 180 is 360. 1 times 180, of course, is 180. If I had pi over 2 radians, 180 degrees divided by 2 is equal to 90 degrees. If I had pi over 3 radians, 180 degrees divided by 3 is 60 degrees, okay? If I have other fractions, it's the same kind of thing. It's basically that fractional part of 180 degrees. So for example, if I have 3 pi over 4, or you could write that as 3/4 pi radians as well, 180 divided by 4 makes a little bit more sense if you divide first, then multiply. You'll keep your numbers smaller. But 180 divided by 4 is 45 degrees. 3 times 45 degrees is 135 degrees. I can have radian measures that are greater than 1. For example, if I had 7 pi over 6 radians, again, that pi radians is 180 degrees. 1/6 of 180 degrees is 30 degrees. So 7/6 would just be 7 times 30, which is 210 degrees. Okay, that is 7/6 of 180 degrees. So very easy to convert back and forth between the two, or at least in this case, very easy to convert from radians back to degrees. It's likewise very simple to go the other direction. If I want to go from radians to degrees, basically I just have to figure out what fractional part of 180 is it. So, or I'm sorry, if I want to go from degrees to radians. So, for example, if I have 100 degrees, I just really want to find out what fractional part of 180 is 100 degrees. And 100 degrees, of course, is 100 out of 180 pi. We can simplify this fraction down a little bit. This simplifies down to 5/9, and we can write that as 5 pi over 9. If I wanted to convert, let's say I wanted to convert 330 degrees to radians. Again, I just want to find out what fractional part of 180 degrees that is. It's greater than 180 degrees, so it's going to be something larger than 1. But basically, I can write that as 330 out of 180 pi. And once again, we can simplify that down. If I divide 3 out of the numerator and the denominator, I end up with 11 pi over, let's see, divide 3 out of both of these, that's going to be 11 pi over 6 radians. So very quick and very easy. Now, you may have noticed a couple things here. When I went through the process here, really what I was doing was I was dividing by pi here. The pi gets canceled, and then I was multiplying by 180. So if you want to go from radians to degrees, if you really love formulas, really what's happening here is I'm taking basically the degrees would be equal to the radians times, and again I have to cancel the pi, so the denominator of my fraction would be pi, and I have to multiply by 180, and you could say that basically to get degrees you can take the radians and multiply by 180 over pi. Again, I don't usually use that formula, but you could use that formula. It's basically the reverse if you want to convert from radians to degrees. If you look over here, what did I do? I multiplied by pi and I divided by 180. So radians would be equal to the degrees times pi divided by 180 degrees, and you end up with your unit there. So you can use those formulas. Again, though, I like to think about what fractional part of 180 degrees I'm working with. And if I use that relationship, for the most part, it works out pretty well. Now, you will occasionally see cases in which you're given degrees or radians, well, specifically where you're given radians not in terms of pi. For example, 3 radians. Let's say I had 3 radians. You could use the formula. If I had 3 radians, I could just take it, multiply it by 180, and divide by pi and get that answer. Another way that you can do it, and another way that you can do any of these conversions, if you're ever stuck or if you're ever not sure, this relationship is always proportional. So for example, if I want to know what 3 radians converts to in degrees, notice 3, not 3 pi. So it's not 3 times 180. I can always do a part to whole comparison. Or basically just I guess in this case it's not really a part to whole, it's a direct conversion. I can do a conversion between radians and degrees. I know that every pi radians is equal to 180 degrees, and I can set that equal to my radians. I have 3 radians, and I want to find the number of degrees. I could call that x, and I could cross multiply. And here I get 3 times 180 is 540. That's equal to pi times x. I can divide both sides by pi, and I end up finding out that x is equal to 540 divided by pi. Now, if you want a decimal approximation of that, you can divide that out. It's going to be a little bit bigger than 150 degrees. 1 radian is actually equal to a little bit more than 57 degrees. So not really a catchy number if you wanted to make that calculation. But if you ever need to, you always can fill in a proportion there. It's just relatively easy in most cases. Usually the numbers that you're going to be working with are things that you can do in your head or with a little bit of writing on paper. So that's the basic idea of radian to degrees and degrees to radians conversions.